we're on to our 1A section notes. This is a review section, okay? This should feel like a review. Remember, I was fighting for my life with the copier, so these copies are totally jacked, okay? Your booklet isn't going to be pretty. There's going to be parts. You can see there's one side blank for you to glue in. It's just not going to be pretty, okay? Don't worry. I fixed the settings. It'll be better next time. All right, but here's our Unit 1A, Section 1, Part 2A notes. Your goal here is by the end of this section, you should be able to say, I can do the following things, okay? That's our goal. I can do this. If there's something up here that you cannot do, then you need to come to tutorial. You need to talk to me, okay? Because everything builds, and this is stuff that we should already have built up. All right? So starting off slow, what is a function, okay? So back in Algebra 1, we learned that a function is a relation that has no repeating x values, right? That was the most simple, basic explanation of it. All right, good explanation. However, we are now mature mathematicians. And because we are mature mathematicians, we do not say that, okay? We say there's exactly one output for each of the input values, right? That's because not everything is an x and not everything is a y, but everything is defined as an input and a output. That's the only difference. It's still the same thing. We're just not using x's and y's. Does that make sense? All right, next. The set of input values is called your domain of the function and is represented by the independent variable. You may have remembered from Algebra 2, I talked about Dixie and Roy. Dixie is the little shorthand way of remembering the synonyms for domain. So you have your domain, you have your input, you have that represents whatever your x value, your x-axis / axis, and then you have your independent variable. I haven't written on this thing in a while, so bear with the writing. She's waking up. The set of output values is called your range of the function represented by the dependent variable. So that's our ROI. Okay, so your range, your output, your y value / axis, and your dependent variable. Those are all interchangeable words. And again, written terrible. Whew, wake up, hand. Going on, Bob. Okay, when we talk about notice this is called a change in tandem, okay? The input and output values of a function vary in tandem, okay? According to the function rules, meaning that they have some type of relationship. That's all that means is that there's a functional relationship, okay? One may go up, one may go down. That is all that it means is that they are operating together in some sequence, okay? That's all the fancy word of tandem. Okay, there are multiple representations that we use to represent a function. And at this time in our lives, we should be able to read and use all 4 forms. Okay, our 4 forms are graphically. We should be able to read it graphically. Numerically is when you're applying to a table or an equation. Algebraically, if I'm telling you this is your input, this is your output, and then verbally. We should be comfortable reading and working with a function in all 4 of these forms. Okay. Anyone hesitant at any of these values? No? Cool. All right. So if you had to graph the point with the input value of 6, that means I'm going where? Input means I start where? I'm going to go to 6 on the x-axis. So I'm going to go to 6 and I go up and the point is at 670, right? We can read that. We can do that. Correct? Yeah, I hope so. Numerically, if I give you an equation, could you evaluate and plug in and find the values? We're only going to do 0 because I don't feel like plugging in the rest of that. But if I substitute in 0, so this is my t, that means everywhere that there's a t, I'm putting in a 0. If I put in 0, what am I left with? 28. That's all I'm left with, right? Because everything becomes 0. But if I have a table or if I have a defined value, I'm just simply evaluating. I'm plugging in, okay? Algebraically, if the input value is t, what is the output value for t, right? So in this case, if my input is t, so I have t of 12.5 is what it's asking me. I can substitute in. I come over here, try to make an approximation. It looks like it's at, I don't know, approximately 75. What I'm going to say. Or am I above 80? I can't see. I lied. 85. It's playing tricks on me. 85? I mean, this is an approximate because I don't want to type, but we're just practicing to make sure we can read. But we understand how all these work. And then the word problem will be setting it up, which is how the image came, right? They create the word problem. My interval is from 0 to 24. Notice that the graph only goes from 0 to 24 as they describe what's taking place. Yes? All right, so those are the 4 ways that we have to be comfortable analyzing any kind of function. All right? And we get better at it and we keep practicing, and it's going to be like second nature. Okay? So here we have, looking at this, the next thing we're going to talk about is where is it positive? So a function f is defined as positive when the graph lies above the x-axis. A function f is defined as being negative when it lies below the x-axis. So when we're describing positive and negative, we are describing when your y. So when we have positive, y is greater than 0. When we have negative, that's when our y is less than 0. Okay? And when we have a zero value, that means that y equals 0. Okay? Positive numbers are y greater than 0. Negative numbers are y is less than 0. And our zeros are when y equals 0. Pretty straightforward. Okay, cool. So when we look here and we're analyzing, state the intervals where g is positive. So we're looking for the intervals where g is positive, meaning where it starts and stops. Things we got to remember about intervals is when they're closed and open. Do y'all remember those things? If we have a open interval, which means that there's a gap, a hole, an asymptote of any kind, that's where we use these inequalities, correct? Strictly, less than, strictly, greater than. So when we define them, that means they're going to be using parentheses, correct? Okay, if we have less than or equal to or greater than equal to, that means that it's a closed interval. It's defined at that point, and we're going to be using brackets. Okay, at any time that it's a negative infinity or a positive infinity, that means that you're going to be using parentheses. So we're going to write the intervals using inequality notation, and we're going to write it using interval notation. Okay. So for the first part, it says state the intervals where g is positive. So I'm going to highlight where g is positive. Oh, I forgot art school doesn't pay for it. So where we're positive is above the x-axis. So g is positive here. Do we see that? G is positive here, and g is positive here. So there are 3 intervals where g is positive, and I would write those 3 intervals. Does that make sense? Okay. So my positive intervals, we're positive from, we read graphs from left to right. So we're positive from -4 up until 0. Do we see that? So from -4 to 0, that's an inequality, or we write it from -4 to 0. Still with me? Our next positive interval is from 5 to 6. So we're from 5 to 6. Because it's defined there, we are at 5 and we're at 6. Our last interval, notice here at 6, it's a what circle? Open. Is it defined? No. So we're at 6, and we stop at 9. So we're at 6 strictly, and we're equal at 9. So this time it's going to be a parenthesis 6, bracket 9. Do we see the difference? All right. So I'd like for you to take a moment. You're going to do the same thing that we just did with the positives with the negatives. All right. No, it don't tell you. So you just got to be able to read both, and it's interchangeable. So like if it's F or Q, you can write either one. You just got to make sure you write it correctly. Okay. Unless it specifies. All right. So let's see what we got. So here, notice here on your left-hand side, this is going from negative infinity, right? It goes forever. So your interval is from negative infinity to, and then it goes up into, where do I stop at? At negative 4. And it's already defined because we defined it here. So then it would be negative 4. Now, this is an unnecessary way of writing something for infinity. So there's two ways of writing this inequality. You can literally write it how I wrote it because you're defining is from negative infinity all up into negative 4. You also can just simply write it when this as x is less than negative 4. So when you have an infinity, the infinity side is not necessary when you have the inequality. Does that make sense? It is good practice because when you write the interval, it is necessary. And when you write the interval, infinities are going to always have parentheses around them. In this case, this one's complete parentheses. So we have negative infinity to negative 4 is our decreasing. Less than, I'm sorry. Negative number. Okay, this one, it is a continuous one. So it should have been from 0 all the way up until 5. We see that? So it should have been from 0 to 5. So we have 0 less than x less than 5. So we're from 0 to 5. All right. And then our last little piece was from 9 to infinity. So you have 9 less than x to positive infinity. And again, in this case, this part isn't necessary. So you can shorthand it and to be 9. I'm sorry. You should lead with the x. This is what we call the mirror effect. X is greater than 9, which means that you're going from 9 to infinity. Now, there is a debate on whether everything should be put parentheses, and that's because when you use equal, that means you're defining 0 as well. And some people say that 0 is not positive or negative. To my understanding, if you put parentheses or brackets, you would be fine as far as it being defined there. I will double check and make sure I'm not lying to you, but I think that's what I read in the grading. Okay. All right. Next is the zeros of the function. So we have how many zeros in this function? Highlight my colors. We have a 1, a 2, a 3, and a 4 zeros. So we have 4 points of defined zeros. When we write them, you're typically going to write them in function notation, okay? So we have f of 4 equals 0, f of negative 4, I'm sorry, equals 0. We have f of 0 equals 0. We have f of 5 equals 0. And we have f of 9 equals 0. Are you comfortable being able to write your zeros in function notation? Easy peasy. All right. All right. So here you go. Uh-oh. Where'd he go? There we go. You're going to go through, and I can bring the pencils or pens, or if you don't want to highlight, but at least identify. If you don't want to go through and highlight with color, you can simply just put eyes. Oopsie. I, D, and C on where those intervals are. So if you don't want the color, you can put an I on the interval, put a D on those intervals, and a C. And then you're going to identify where they are. So quickly, because we did do this, so this should be a fairly quick review. And go. Yes, you can. Yeah, you're good. You go until it changes the directions. Yeah. Oh, I chose the wrong color. I need a red. 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 Ding. Oh, curious. You were supposed to just pretend that it was perfect. Why did you have to call it out? Why? Fine, I'll fix it. All right. Those should be your intervals. How do they look? Okay. Your green, you only have one green because we read from left to right. We only have one interval of increase. That one interval of increase starts at, we're just going to say 0 for the sake of ease. Is that cool? We're going to say from 0 to 2. So we go from 0 to 2. Okay. When we're writing intervals of increase, we're going to use brackets. Okay. When you're describing increase, decrease, and constant, you're going to always use brackets. Unless there's a set point that's like, no, I'm not here. I'm a ghost. We have two intervals of decrease. So our first one is from negative infinity all the way up until 0. So we're going to go from negative infinity to 0. Our second interval of decrease is going to go from 5 to positive infinity. Yes. How do we do? And then our little happy little constant is from 2 to 5. Are we good? Remember, everyone remembers intervals of increase, decrease, and constant. No one was like, I've never learned that before. Good. Don't lie on my name. The next part of this is defining intervals of increase and decrease. Okay. And again, we define everything as we read from left to right. Okay. So we read everything from left to right. So when you're following along, you're saying, where is it increasing from left to right? Okay. This is our key concept, is that a function is increase over an interval if your A is less than your B, then your f of A is also less than your B. That just means that if your inputs are in numerical order and one is the smaller one is to the left, and your outputs are in numerical order and the smallest one's to the left, then that's how you know that it is a steady increase, because you're growing as each one goes, right? So as my x's get larger, my y's are getting larger. So if you want to think about it in like layman's terms, x increases and y. That is not the mathematically way of saying it, but that's the visual way. Your x's are increases and your y's are increasing. No, you missed it by 5 minutes. You missed it by 5 minutes. What time is it? 9:25? Is it 9:25? Oh, it stops at 9:25. I don't know how fast you would be, but yes. Okay. And then decreasing. So as your x's are increasing, your y's are getting smaller. They're decreasing is what that means. Okay. It's constant is as your x's are increasing, your y's are staying the same, correct? So we have our increase, our decrease, and our constant. Got it? This is your baseline algebra 1. Can you define domain and range of any function given any way it looks? Okay. So when I look here, it says find the domain and range of each of the relationship, determine the relationship is a function, given a reason to justify your answer. So in this case, this is what we call discrete data. Okay. it is not going on for forever, which is called continuous data. This is a specific set of data, which means that you have a specific domain in a specific range. Does that make sense? When we write our domain in range, we write it in numerical order, whether from increase to decrease, or decrease to increase. Well, so least to greatest or greatest to least. And we do not repeat the values, okay? So when we're defining our domain, your domain here, it's going to be defined as your X values. And in this case, you're going to write them in order from least to greatest. Now, please do not make fun of my braces. I'm the worst braces drawer there is. And we're just going to go with, hey, that was not that bad. All right, what is my smallest value of my domain? What's my smallest value? -3, then, and then 2. And that's my domain, correct? Again, don't question Miss Jones's braces. The range of my data, I'm doing this fairly quickly because we all should be able to do it. So your range is defining your Y values from least to greatest. My smallest is -4. Then we have, and 6. Okay. Remember, we do not repeat the values in the domain and range. Okay. Is this a function? Yes, it is. Yes. And why is it a function? We can't say that X so many people can. This is our magic way. Each input has one and only one output. That's our reason. That's what we write now. Okay. Each input has one and only one output. So if you're on a test and it asks you, why is it a function? What is it saying we're writing? Perfect. Okay. So this guy, our domain here, I'm just going to label it. Is that okay? This is our domain and this is our range. What is wrong with our domain? Is this a function? No. Why is it not? There we go. Not every input has one and only one output. Does that make sense? So that's why it is not a function. Okay. The purpose of this was to go over those two terminologies. Okay. Because that's how we have to write that if something is a function or not a function. We can't just say repeating X's and repeating Y's. Got it? All right. So I know you know how to do domain and range, but I just wanted to go over with the phrases that we have to use. Correct? Cool? All right. Are we good with that? Okay. So our terms here, I should make a poster of this, right? I should. I need to make a poster and hang it up right there. Each input has one and only one output. Note to self, make a poster for the class. Got it. All right. Next, you will need to be read carefully. Stating F is positive is different than saying that F is increasing. Okay. What we're leading into is that we can't just say F is positive and assume that that covers all the bases. That does not mean one thing. So, what I want you to do is I want you to sketch based on what the description is, what you think that graph looks like. Okay. So if I told you to sketch a graph, so on A, sketch graph G, and it is negative and increasing. So G is negative and increasing. What do you think that looks like? So G is negative and increasing. What do you think that looks like? G is negative and increasing. I want you to just sketch. What do you think that means? And you're going to also then sketch H. It's not a wrong or wrong. It's okay. It's just notes, guys. Okay. There is a wrong. I'm about to say there's not a wrong answer, but there is a wrong answer. But there's no wrong way of trying. How about that? Yeah. Okay. The graph of H is positive and decreasing. So I want you to illustrate what you think those look like. All right. So key thing here is it says that G is negative. G being negative means that G has to be below the what? It has to be below the x-axis. That's what this negative piece is telling me, is that it is below the x-axis, okay? And it has to be increasing, which means that from left to right, it has to be going up. So you could have drawn something as simple as this. Here's my y equals g of x. Is it negative? Because it's below the x-axis. And is it increasing? Yes. Okay. What about if I asked you to draw h is positive and decreasing? Well, h being positive means that it has to do what? It has to be above the x-axis, and decreasing means as I read it from left to right, it is going down. So as long as it's above the x-axis, then bam, I followed the rules. Okay. So after doing this, we should be able to understand that being positive and negative are two different, positive and negative, and increasing and decreasing are two separate concepts. They can come together and create one graph, but they are two separate concepts. Agree? Do we see that? Are we okay with that? All right.